Hello students, welcome to Sarasa classes. Today we are solving chemistry 2021-22 NSEC paper. We have to attempt 30 questions over here, part 1, A1, and out of which only one of the option is correct over here. And we have to bubble out the correct option. 1 mole of neon gas is given, which is 20 gram per mole, and 1 mole of argon is given, which is 40 gram per mole. They are stored in two separate containers, 1 and 2, at temperature T and T2 respectively. If the gases are assumed to behave ideally, then we have to find out the kinetic energies and the average velocity. So kinetic energy for the gases we know is 3 by 2 RT. So kinetic energy for container 1 will be 3 by 2 RT, and kinetic energy for container 2 will be 3 by 2 into 2t. So say this is equation 1 and this is equation 2. Then it will give us kinetic energy 2 is nothing but twice of kinetic energy of container 1. Obviously of the molecules I meant. And for C average, we know the formula is 8 RT by pi m. So for kinetic energy, C average for container 1 will be what? We will say T remains as T and the neon is the gas over here. So it is 20 pi, and for kinetic, the C average for container 2 we will say, using the same formula, 8 or 2t, okay, 8 or 2t divided by 40 pi, because the gas molecule in container 2 is nothing but the argon. And now if we compare, we will say both the average energies, average velocities for the gas molecules in container 1 and 2 are the same. So average velocity is same, but the kinetic energy of container 2 molecules is double the kinetic energy of container 1 molecules. So over here, option C is the correct option. An aldehyde ketone in the presence of a base forms a carbon ion at the alpha position, which can react with the carbonyl group in aldol type reaction. It can also react with the olefinic bond, like a Michael type of addition reaction, which is activated by groups like COC and NO2 attached to the double bond. The latter reaction is an addition reaction across the double bond. Violent mixture ketone is an important synthetic intermediate used to synthesize many compounds. So we have to find out basically over here the pair of starting materials suitable for the preparation of this ketone through a base catalyzed reaction. So basically what they are asking is to disconnect this compound, and that is what I am going to show to you. Okay. So while disconnecting this compound, first remember you have to disconnect the alpha beta bond of the unsaturated ketone. So this is the alpha position and that is the beta position. So you disconnect the bond over here, and that gives you minus minus, because you're doing a heterolytic cleavage, plus plus. Where it is plus plus, you join O2 minus, that means this one, and where you have minus minus, you join there 2 H plus protons. Okay, and so that will give you the following material. Now out here it is important to notice that this portion, that is this one, is a 1,5 dicarbonyl compound. Okay, so for finding the starting materials of a 1,5 dicarbonyl compound, we have to first of all number them out. Okay, so we number them out as 1, 2, 3, 4 and 5, or we can do the reverse also, something like this. So this is the methyl and that is the O. So I'm numbering from 1, 2, 3, 4, 5. Okay, and now I have to think that I have to break at the 3,4 bond. Okay, so this is the point where I am going to cleave the bond. Okay, like this. And so now my starting materials will be having something like this. So it will be there is a minus sign here, there is a plus sign here because you have broken only one bond. So for that we are having plus and minus sign. Alright, another heterolytic cleavage. So wherever there is a plus sign, you think of removing this proton to find out the Michael acceptor, and this is your Michael donor. This is your Michael acceptor. So over here where there is a minus charge, you just add there a proton. Okay, and so your starting products will be as I have shown over here. Now if you compare, you will see your correct answer over here is option B. Okay, next question is X in the following reaction: 2-methyl propanol, formaldehyde is in excess, calcium hydroxide is a weak base. Okay, that has to be kept in mind, and that is the most important part. So when in case of weak bases, it will not promote Cannizzaro type of disproportionation reaction. Rather over here, we will say aldol type reaction is more preferable. We have a alpha H proton over here. So what will happen over here is this base will take up this proton, and we know formaldehyde is more reactive than 2-methyl propanol. So over here this minus charge will now make a nucleophilic attack over here, all the steps being reversible in nature. Something like this intermediate will be formed, which will add a proton, and this type of a intermediate aldehyde will be formed. Now since there is an excess amount of CHO, HCHO, so over here now what will happen is this molecule and the formaldehyde both do not have any alpha proton, so a Cannizzaro type reaction will now take place over here, in which the OH minus will make an attack over here, which will go like this, and this will give you an intermediate of this type. This will come back, so this will now make a nucleophilic attack on this particular carbon that will open up. So ultimately what you are going to get over here is OH, H, H, 2 methyl groups, OH, Proton exchange means this will now become OH. So this is basically your, I would say, 2,2 dimethyl 1,3 propanediol, and that would be our correct answer over here. Along with that, another side product will be formed, which is obviously the formate ion. Okay. Next question: among the following, among HCl, HClO, HOClO2, HOClO3, which cannot undergo disproportionation reaction? So we will say as a theory that disproportionation does not happen when elements are present in their present in their lowest or highest oxidation states. So if we check for HCl, it is Cl-1, which is the lowest oxidation state possible for chloride. And this one, that is HOClO, it is present in oxidation state plus 3. This is present in the plus 5, and this is present in the plus 7. So out here we will say that option 1 and 4 are the correct options. Question 6 given: the electronic transition in He that will occur at a same wavelength as that of the N2 to N1 transition in H atom. So for this the formula is so this is for the H atom, let's say, and that is going to be or we can say lambda is nothing but it is 4 by 3. Now for the He plus ion, we will say 1 by lambda, okay, RH ZHE plus square 1 by Ni square minus 1 by Nf square. So this will be equal to 3RH by 4 only when Ni is 2 and Nf is equal to 4, and so the correct option over here is going to be D. Okay. The next reaction given is P, which we'll discuss in the next slide. Question number 7, P in the following reaction. We have been given basically over here a gamma hydroxyaldehyde, okay, and that is being treated with H3O plus. So over here the aldehyde will undergo protonation, okay, and that will then react with the all. So basically this will lead to the formation of a molecule something like this, which we can say will lose a proton. So basically we are thinking this is going to be our something like a hemiacetal, okay, which if we react with another molecule of alcohol, okay, in presence of acid, then in all possibility this should form now the acetal molecule, okay, and that should be our product. So over here C should be the correct answer. The number of stereoisomers is maximum for, so we have been given basically a bidentate ligand which is oxalate. So for this one, which is a MAA whole thrice type molecule, we will have only optical isomerism, and there will be two of them, okay. So this will give you two isomers, whereas for this one, number B, this will show, this is basically MAA BC type, okay. So number B will show, we will say geometrical isomerism, in which we will say it is having cis and trans, okay, out of which the cis one will be showing your optical isomerism. So in total we will say there are 3 stereoisomers, okay. If you want to check what these are, then we will say, I'm just giving the general notation, okay. So we have, say, the MAA, okay. This is AA is your bidentate ligand, that is your oxalate, okay. And then you can have your B and C. So we are saying B and C are basically bromine and chlorine, okay. So this is your, say, trans, and for your cis, we have A. This is your B and C. So that will be one of the cis isomer, and for that, since this is having no plane of symmetry or center of inversion, we will say it will be showing optical isomerism of the following type. Okay, so in total there are 3 stereoisomers for B. Okay, for C there will be in total 4 isomers. All right, and those can be, so this is of what type? We will say this is MAA B2C2 type. Okay, so for that, obviously this also will have a cis and trans isomer. So we are having, say, AA, CC, and the B are now trans to each other. This is one of it. The other trans isomer obviously is AA, C, C, okay, and BB, this type. The other one will be, so both are trans over here, okay, and the other one we can think of what, when C and B are trans to each other. So this is the one. Okay, this is the other one, and as we can see, this particular molecule is having no plane of symmetry, I mean this one. So we will say there will be a mirror image for it. So this is all cis. Okay, and this is having C trans. This is having B trans. So for this one, we will say there will be a mirror image of the following type. Now for the last one, which is obviously MA3B3 type, this is going to show FAC and MER geometrical isomerism, and hence there are 2 of them. So the maximum number of stereoisomers obviously is for option C. Maximum number of electrons with ms half, which can be accommodated in the subshells having total 3 nodes. So over here 3 nodes means, let's say, radial nodes. Given by n minus L minus 1, So over here, when the orbital is 4s, then it is going to have 3 nodes. When it is going to be 5p, 3 nodes, 6d, 3 nodes, 7f, it is going to be 3 nodes. Okay, because we know the value of L when it is S. So if we have a, say, L value for orbitals, if it is S, it is 0, for P it is 1, for D it is 2, for F it is 3. Okay, and if you use these values along with the N values, we will be getting 3 nodes. Now it is saying ms plus half and not minus half. Okay, so that means the 4s orbital is having, it can hold 2 electrons. Similarly, 5p can hold 6 electrons, 6d can hold 10 electrons, 7f can hold 14 electrons, but only ms half. That means here we are going to have 1 electron, here we are going to have 3 electrons, here we are going to have 5 electrons, and for 7f it is going to be 7 electrons. And if you add all these, the value comes out to be as 16. So the maximum number of electrons with ms half, that is plus half, which can be accommodated in subshells having 3 nodes, the answer is going to be 16. Next question, number 10, it says Hinsberg test of the compound X produces a solid Y that is insoluble in 10% aqueous acid, and Y is going to be dissolved by sulfuric acid. So Y, if it is going to be dissolved by 10% sulfuric acid, that means Y is basic in nature. Okay, Y is basic in nature, and it is saying it is insoluble in 10%. So something that is insoluble in NaOH, that means it itself is a base. And out here, this is a test that can only be given by 3-degree amines. So if you check which are the 3-degree amines, this is obviously a primary amine, so it is wrong because this is primary amine. Here also it is primary amine, wrong. Here it is 3-degree amine, and then we have another 2-degree amine. Okay, so this also is wrong. So both the nitrogen should be 3-degree, and that is only possible for the option D. So D is the correct answer over here. Okay. In question number 12, it is being said in compound X, the number of chiral centers and the number of peptide linkages are respectively what we have to find out. So whenever they are saying peptide linkage, that means it has to be C double bond O and NH, this portion. Okay. So if you check that, then we will say over here we are having, this is the peptide linkage, and another peptide linkage is over here. So there are 2 peptide linkages. When we consider chiral centers, then this is one chiral center. Okay, this is also another chiral center. This one is having 2 hydrogens, so it is not a chiral center. So obviously we will say the number of peptide linkages are going to be 2, and the number of chiral centers are going to be 2. So obviously option C is the correct answer. Which of the following is not an example of a Lewis acid Lewis base reaction? So this Lewis acid base reaction can never be a redox reaction, first of all. Okay. In a Lewis acid base reaction, the coordination number can increase. Okay. So here we can see in the first option itself, zinc 0 is becoming zinc 2 plus. So this is the correct answer, obviously, over here. And the rest of the reactions, as you can see over here, the I2 is combining with the triiodide to form polyhalide. COCl3 is converted to COCl4. So basically the coordination number has increased from 3 to 4. And this is basically SO3 is undergoing hydration. Okay. And it is forming. So SO3 is acting as a Lewis acid and the water is acting as a Lewis base. Okay. Here chloride minus is acting as a Lewis base and CO in the COCl3 is acting as a Lewis acid. Okay. Question number 15 says an oxide is soluble in NaOH, oxide B in HCl, oxide C in both. So C is obviously a amphoteric oxide, B is a basic oxide, and A is a acidic oxide. The correct state of ABC we have to find out. So carbon dioxide is acidic oxide, Na2O is a basic oxide, and ZNO is an amphoteric oxide. So option B is the correct option over here. Question 16 says ascorbic acid, vitamin C, a naturally occurring water soluble vitamin and abundantly found in lemon, shows antioxidant properties. In ascorbic acid, the OH with the lowest pKa, that means the most acidic proton we have to find, right? We have to find out the most acidic proton. Okay, because we know H plus ion concentration is inversely proportional to pKa. Lower value of pKa means, so over here, if we check, we have been given 1, 2, 3 and 4. Now, if we think that we are taking away this one or that one, okay, we are not considering 1 and 2 at all because they are connected to sp3 carbon, okay, and we are considering 3 or 4 over here because they are connected to sp2 carbon, and sp2 carbon is more electronegative than sp3 carbon, okay. Now if you deprotonate 4, then one can say that the minus charge is going to come out here, okay, like this. And if you think we are giving this charge back and creating a double bond O, then the double bond over here will break and come here, like that, okay. However, if you think that we are creating a minus charge over here, like this, and this goes to common double bond O, then there is the charge will come here, something like that. We are not considering the above part. Now this charge can be further delocalized over here via resonance, and we know whenever the conjugate base gets resonance stability, the acidity of the proton will increase. So over here we will say 3 is the correct option, and the proton with that will be having the lowest pKa. Over here we have been given compound X gives positive silver test, that means it is giving test with the Tollens reagent. That means it is having an aldehyde. Or a alpha hydroxyketone. Yellow precipitate with I2NOH. So it is also having the ketomethyl group, because this is giving iodoform test. Okay, so let's quickly draw the structures of the molecules. So when it says 2,2,2-hydroxy 3,3 dimethyl cyclopentanone. So our cyclopentanone, if we draw like this, it says 2-hydroxy. That means over here. Okay. Rather, I should say this is going to be over here. 3,3. Rather, I should say this one is the correct one. Okay. 2-hydroxy 3,3. Okay. So this is the compound over here, and we see that we are not having any aldehyde group over here in this molecule. So this is not the correct option. 2,5 heptadione. So let's draw a 7-membered ring. Heptadione it is saying, so obviously 1, 2, 3, 4, 5, 4, 5, 6, 7. So this is the molecule they're talking about. This is 2, 3, 4, 5. So again, this is having a ketomethyl group, no doubt, but it is not having any aldehyde group. So this also is the incorrect option. Next we have 2,2 dimethyl 3-oxopentanal. Okay, so let's draw a pentanal first. Let's draw over here. This is 1, 2, 3, 4, 5. Okay. And we have this one. So again, this is having no doubt the aldehyde group, but this is not a ketomethyl group. Okay. So this also is the incorrect option. The last option, obviously out of elimination, will be the correct answer. But let's draw the structure to understand it in a better way. 2,2 dimethyl 4-oxopentanal. Okay, so what is that structure? It is going to be like this. So 1, 2, 3, 4, 5, right? 4-oxo. So this is the 4-oxo. So now we can see it is having the ketomethyl group, also the aldehyde, and so it will be giving the test. All right. Now here we have been given, if the ratio of the concentrations of the oxidized and the reduced species, reduced forms of a species in a electrochemical reaction can be given as shown over here. So what should be the correct answer? Now in question number 18, it is given If the ratio concentrations of the oxidized and the reduced forms of the species in an electrochemical reaction can be given as ox by red equal to 10 to the power minus 3, the correct expression among the following at 25 degrees centigrade is, we have to find out. So over here the Nernst equation is as shown, and if you just plug in the value, then we can say E naught is equal to 3 into 0.0592 by n, and we know log 10 is actually going to be 1. So this is E. So we can rewrite this expression as E minus E naught equal to. So the answer over here is going to be B. Among the following numbers, the one in which all the zeros are significant, obviously option A. Among the following, question number 20, set of compounds, the one in which a reaction between them followed by hydrolysis that does not lead to the formation of 1-phenyl 2-butanol is, we have to find out. Okay. So we have been given as phenyl acetaldehyde. So obviously that is this is your phenyl acetaldehyde reacted with ETMG Br followed by hydrolysis, and the compound that will be formed obviously is going to be 1-phenyl 2-butanol. Okay. Butanal reacted with phenyl magnesium bromide. So what is butanal? And if you react this with PHMG Br followed by hydrolysis, this will not give you the desired 1-phenyl 2-butanol. Okay. So this is the reaction, and that will be the correct answer. If you are given propanal to react with benzyl magnesium bromide, so we are given propanal, and that is being reacted with PHCH2MgBr followed by the hydrolysis, and that will give you obviously the desired 1-phenyl 2-butanol. Similarly, if you react the 1-phenyl 2-butanol with NaBH4, you will get the desired product, 1-phenyl 2-butanone. 1, 2, 3. So if this is treated with NaBH4, then we get the desired product, 1-phenyl 2-butanol. Question number 21 says the correct order of CFC of the following complex ions: ZnNH4 plus. Obviously, it's a tetrahedral system. Apart from that, this is D10, so CFC will be 0. Cobalt NH3 6, so this is a D7 system. Okay, and this will be high spin. This is a D6 system, cobalt NH3 whole 6 3 plus. This is a low spin system, so this will be having high CFSE. Then the cobalt 2 system, cobalt 2 hexa amine complex. And then we have IR NH3 whole 6 3 plus. So this is also D6, and this also will be low spin. Now we know certain facts about CFSE, and that is, if we go down the group, then CFSE obviously increases. That is one fact that we know. And so we will say that IRNH3 whole 6 3 plus will be the having. Question number 21 says the correct order of CFEC of the following complex ions. We have to find out. Now ZnNH3 whole 4 2 plus, this is zinc 2, so this is a D10 system, and CFSE over here is going to be 0. CONH3 whole 6 2 plus, this is a D7 system and a high spin, that too. CONH3 whole 6, this is a D6 system and this is low spin. Cobalt 3, except for fluoride, for all other ligands it is going to be low spin, one should remember. And IRNH3 whole 6 3 plus, this is going to be also D6 system and low spin. We know CFSE, if we go down the group, it increases because the size of the orbitals, d orbitals, they increase, and so it is increases. And so we will say this is going to be IRNH3 whole 6 3 plus. This will be having higher value than CONH3 whole 6 3 plus. So that way, if we check out of A or C, one will be the correct option. Now octahedral complexes we know are greater than tetrahedral complexes for always. Now let's find out. Suppose this is cobalt 3 system, and another one we have cobalt 2 system. Okay, so in a cobalt 3 system we will say 1 2 3 4 5 6. This is your T2G and that is your EG. This is your T2G and that is your EG. Cobalt 2 is a high spin system. So CFSE over here is coming out to be, we will say, minus 0.4 into 6, that is going to be minus 2.4 delta O. Okay, that is what it will be. And for the cobalt it will be what? CFSE, it will be minus 0.4 into 5 delta O plus 1.2 delta O, and that is going to be, we will say, 0.8 delta O. So from these facts we will say this one will be higher than cobalt 3 hexa aqua complex. Hexa ammonia complex will be greater than cobalt 2 hexa ammonia complex, and so we will say option A has to be the correct option over here. Solvents are classified as polar and non-polar based on their dipole moments. Given below are the solvents: 1,2 dibromobenzene. So this is going to have some dipole moment, or we will say non-zero dipole moment. So mu out here is going to be 0. So this is a polar system. Q is basically the following molecule, which is diisopropyl ether, and then we have R, which is trans 1,2 dichloroethene, and here the dipole moment is equal to 0 for sure, because CCl bond moments are cancelled. So this is non-polar. So any option that is having R is going to be non-polar. Cancelled, cancelled, cancelled. Simply by elimination, we can say our correct answer is going to be A. Similarly, we can say S is polar because it is 1,2 dichloroethane. Okay. Here CC bond rotation is allowed, so mu out here is not equal to 0. And obviously N-ethyl methyl propanamine. Okay, this also will have dipole moment not equal to 0. Out here it is given which of the following statements are correct. Half-life is 50% of the total time taken for completion of a reaction. This is true statement. Collision frequency Z, which is the number of collisions per second per unit volume, is same as the rate constant of the reaction. This is not correct. Change in activation energy of the reaction at a particular temperature will result in the proportional change in the rate and rate constant of the reaction at the same temperature. Rate and rate constant remains fixed. Okay, so it cannot change. So this statement is wrong. All first order reactions are not unimolecular, which is true. For a zero order reaction, the slope of T versus the initial concentration will be 0. This also is not true. So out here the correct options are going to be 1 and 4. The orange color of K2Cr2O7 and yellow color of K2Cr04. So this is basically dichromate and chromate, okay? And this is chromate. In both, the chromium is in +6 oxidation state and oxygen acts as a weak field ligand over here. The color over here, because chromium is basically in 6 state, it is D0 system, but yet they are showing color, and that is because charge transfer from oxygen to chromium. So this is basically ligand to metal charge transfer over here taking place, LMCT. And option C will be the correct option over here.